In this video, I'm going to cover measures of position. So, let's see what objectives I'm going to cover here. Determine the quartiles of a data set. Determine interquartile range of a data set. Create box and whisker plot. Interpret other fractals such as percentiles, and determine and interpret the standard score, z-score. Okay, we are going to cover every single object here. So, fractile. What is fractile? When you partition or divide some ordered data into equal parts, and each part we call fractile. So they have to be broken into equal parts. Next, quartile. When you break down into 4 equal parts. So each part we call quartile. So quartile, it's remind you as a median. Let's see. First quartile, second quartile, first quartile. For example, if this is your database, so this will be your Q2, which will be your median. You arrange in ascending order. So then you find Q2, then this upper lower part of piece you break down and get median for this low part. That will be Q1. And then find the median for the upper one. That will be Q3. So those are 3 quartiles that break down entire database into 4 parts, equal parts. Okay. So here is example, finding quartiles. So let's see where we can use this quartile. The number of nuclear power plants in the top 50 nuclear power producing countries in the world are listed. Find the first, second, and third quartile of the data set. Okay, we have top 15 power producing countries. Okay, there are 15 countries, and every country has some certain amount of nuclear powers. So we need to find first, second, and third quartile of the data set. So what we are going to do, first thing, to find the quartiles, we have to arrange them in ascending order, the entire database. Here it is. We have in ascending order, lowest 6, the highest 104. What are these numbers? Those are countries. How many nuclear power have these countries? Some country has 6 nuclear power, some 7, some 10, 15, 17, 18. Wow, here we have 104. Take a guess which country has 104 nuclear power. Well, I had in my class military student, and he told me with responsibility that United States has 104 nuclear powers. When I asked him how does he know that, and he said they learned it. So United States has 104 nuclear powers, and the others, all other countries in the world. Okay, and as you can see at numbers, 104 is an outlier. Nobody has even close to what has United States. Okay, so let's find first quartile, second quartile, and third quartile. We start with the second quartile, not the first one, because it will be difficult to break down into 4 pieces just like that. The easiest way is make a half, and then that will create 2 halves, and then take each half and break into another half also. So the bottom line is, if we have 15th, so the 8th element, it's going to be your median, which is your quartile, as a second quartile, also known as median. Okay, so that breaks into lower half and upper half. Now let's find the Q1. So if we take this low part of interval between 6 and 17, right? So what will be median here? It's gonna be Q1, 10, which will gonna be 10 because you have also odd number, right? So the median middle position, it's gonna be your median for this lower half. And upper positions, you have also 7 elements. So the position, the fourth position, starting from 18th, this 18th, and goes all the way to 104. That will be Q3, which will be the median for the upper half. Now, why do we learn quartiles, and what is good about this quartile? So practically looking at this database, we can say that you see Q2, that's a median for entire database. So we can say that almost 50% of the countries have 18 or less nuclear powers. Okay? 50% of these countries have 18 or less nuclear powers. Okay, so in 3/4, it has 31 or fewer. So Q3, it will provide you 75%, correct? Because if you divide by the 4 parts, then it's gonna be, each part is gonna be 25%, right? 25, 25, 25, and 25. So from the beginning all the way to Q3, it's gonna make 75%. So 75% have 31 or fewer nuclear powers. Okay, so it's kind of analysis of the database. Interquartile range, IQR, interquartile range, the difference between third and first quartile. So if I have here, let's say my database, this is Q2, this is Q1, this is Q3. So the distance between Q1 and Q3 we call IQR, interquartile range. Okay? IQR, interquartile range, is equal Q3 minus Q1. Okay, let's find interquartile. Why do we want to find out interquartile? Because it will match to centralized data on, forgot the name of the graph. Jesus Christ. Okay, I will remember. Where we have centralized data, right? So that's, we take the data that are centralized and we explore the data that are centralized. And this piece is matching to our interquartile range, which is equal Q3 minus Q1. 1. Okay? So what is the interquartile range in this data set? So Q3 IQR is equal 31 minus 10, which will be 21. Okay? All right. So the centralized data are within 21 nuclear powers. Here it is. The number of power plants let me take a red one. The number of power plants in the middle portion of data set can vary at most by 21. So now let's explore data analysis tool, box and whisker plot. So how many elements do we need for box and whisker plot? We will need 5 elements, minimum, maximum, and all 3 quartiles. Those are 5 elements we will need to build box and whisker plot. So if this is box and whisker plot, it's another tool analysis, just like we explored, analyzed some business example based on graphs, right? Stem and leaf, dot plot, correct? Okay. So how are we gonna draw box and whisker plot? Those are steps, which I'm not going to read it. All I will show you, this is how it's gonna look, box and whisker plot on the graph. This is our box, blue color. Here you have Q1. This point is a Q1. This point is Q3. And middle point is gonna be median. Minimum value, maximum value. Minimum and maximum can be with the possible outliers, okay? And those are whiskers, we call. Whisker, also whisker. So that's what we're gonna build and then explore, analyze this plot. Okay, so let's draw the box and whisker plot. Here we go, the same example with nuclear power plants. So we have minimum is a 6, maximum is 104, and we have Q1, Q2, Q3. All right, minimum is 6, here it is. Maximum is 104. Here it is. So Q is 10. We are building. Q1 is 10. Q3 is 31. Q2 is 18. So what can we say here? We can say that data are skewed towards bigger number, right? So mean will be skewed towards bigger number, and that 104 is a possible outlier. So this is where data are centralized in the whisker and box and whisker plot. This is where our data are centralized, and because this median, you see, looks like skewed, so it's skewed towards uppercase box, we call that the data are skewed towards higher number, which means mean is skewed towards higher number. Okay? About half of data values are between 10 and 31, and indeed, this is 10, this is 31, okay? And 104 is a possible outlier, I already told you. Okay, next, fractals can be broken into quartiles, deciles, percentiles. Quartile is a quarter divided into 4 equal parts. We call Q1, Q2, Q3. Decile, everybody is familiar with decile. It's decimal equal parts, which is going to be 10 equal parts. D1 through D9, that make 10 pieces. And percentile, widely known 100 equal pieces, which we break down P1, P2, P3, all the way to P99. Okay. And lastly here, I'm going to cover standard score, z-score, represent the number of standard deviations a given value x falls from the mean. All right, let me explain. We're going to work in details about standard z-score starting from next chapter, no, chapter 4 I believe, because chapter 3 is going to be all probability. And that's when mainly I will start covering z-score. I don't know why they put that piece here. So in this case, all I will do, I'll just explain, tell you that z-score is equal value, which is x, value, which is x, minus mean, which is mu, and divided by standard deviation. So for now, that's all is enough for you to know the formula, because in chapter 4, I am going to cover in very details, because this score, standard score, is crucially important topic. It's a core topic of this course. Therefore, I don't want to explain a little bit, tiny bit here, and then move to chapter 3, which will be completely about probability, and then only in chapter 4 we will cover this z-score. All right, give me 1 second, please. I'm going to turn my conditioner up. I'm freezing here. 1 second. Okay, let me see. If I have some more slides, I'll explain a little bit, but I don't want to go too much in details. Okay, here it is. Okay, well then there is a problem, word problem. I'll explain a little bit. Okay. What is z-score about? Let's assume I have in my class, let's say, some student that called me after taking the test with entire class and asking me, and he got 87%. So he's asking me, Miss Nara, how did I do? So based on average grade of average score of student of entire class, student will figure out if he either did good or he didn't do well, because if his score is above average, he will be happy, but if his score is less than average, then he won't be happy. Now z-score is showing how many standard deviations the value of x is drifted away from the average. Okay, So z-score is a standardized going to be table of z-score, where we can figure out that z-score is going to be between negative 3.49 minimum and positive 3.49. Now z-score is showing how many standard deviations the element x is drifted away from the average. So right middle is 0. That means it's going to match to your average. Okay, so below 0, it's going to be below average or z-score. That's here equals 0 when it's matching to average. Above mean or above z-score equals 0, it's going to be positive z-score, because we have here positive 3.49. Why do we do that? Because standard deviation can be enormously big value or enormously small value, so, and its calculation is complicated. Therefore, it's been standardized through z-score. And there is a table of z-score that we are going to learn, and that's how we are going to figure out or find all answers on questions that we will have in upcoming lectures. But for now, I'm going to solve very basic problem, so you give you a flavor of understanding what z-score is. Here is a word problem. In 2009, Heath Ledger won the Oscar for Best Supporting Actor at age 29. So age 29, hold on, let me change on red one. At age 29, so who is it? Heath Ledger. Oops. Heath Ledger at age 29. Okay. The Dark Knight, in the movie The Dark Knight, Penelope Cruz won Oscar for the Best Supporting Actress at age 34. Okay. For her role in Vicky Cristina Barcelona. The mean age, average age of the Best Supporting Actor winners is 49, so average for men actors is 49.5, with standard deviation sigma for men is 13.8. Okay. The mean age for Best Supporting Actress women is 39.9, with standard deviation 14. Find the z-score that correspond to the ages of Ledger and Cruz. Okay, now Heath Ledger is gonna be, we are going to identify as our X for Heath Ledger. 34, it's our X for Penelope Cruz. Okay, those are our data. Let's see. So for Heath Ledger, this score is equal X minus mu over sigma, where X was age of Heath Ledger, 29. Mu was the average age for men, for Oscar, 49.5, standard deviation, 13.8. So once we solve it, we are getting this score is negative 1.49. Okay, so our average of z-score is right here where it's 0, right? Z-score is equal 0. Here we have negative 3.49. Here we have positive 3.49. Negative 1.49, let's assume is here, negative 1.49 here, which tell us that Heath Ledger got his Oscar at much younger age than average of the Oscar winners, right? Because it's below, even earlier, at much younger age. Now let's see Penelope Cruz. Penelope Cruz has X minus mu, so 34 was age, minus 39.99, that's average age for the actresses winner of Oscar, and sigma is standard deviation, which was 14. So we got negative 0.42. So what does that mean? Negative 0.42, that means it's closer, right? 0.42, it's closer to 0 than negative 1.49. So what can we say? Comparing Heath Ledger to Penelope Cruz, we can say that Heath Ledger got in much younger age comparing to other men that would got the Oscar, rather than Penelope Cruz that was slightly she got slightly earlier at earlier age, younger age than average of women, because negative 0.42, it's only a little bit below our average. Okay, that's the comparison of these scores you can figure out. And here it is. Both these scores fall between negative 2 and 2. So if we look here, negative 149 is greater than negative 2. And negative 0.42 also greater than negative 2. Okay. So let's see, this is our spectrum of our z-scores. This is here will be negative 3.49, here positive 3.49. This is how the spectrum is broken down. If it's between negative 2 and positive 2, we consider as a usual score, which means both of them got at their usual age. Comparing to average age, they both got a little bit younger, but per se, if you won't count average, so that means there were people who got at this age. Because we're comparing only to average, it doesn't mean nobody got Oscar at their age. Now, between negative 2, negative 3, between negative 2 and negative 3, we call it as unusual, this pink color. It's taken as an unusual. And between negative 3, keep going. Between negative 3 and negative 3.49, this piece, then it's absolutely rare, very rare. So which means, looking at this spectrum, we can say, comparing with other Best Supporting Actor winners, Heath Ledger was relatively younger, whereas the age of Penelope Cruz was only slightly lower than average age of other Best Supporting Actresses. Just exactly what I mentioned a while ago. Okay, so that was understanding of Z-score. A little bit, slightly, it's just a flavor. So like I said, we will learn heavily, we will use this core in chapter 4. So this is all. We learned what quartile is about. We learned how to identify interquartile, created box and whisker plot, made interpretation on fractals such as percentile, and figured out the score. All right, see you in chapter 3 recording.